Hi guys, this is Mrs. Hain. I'm going to be reading your Earth's History Assessment to you today. A couple of things before we get started. Remember to put your name, the hour that you have Mr. Mulder, and the date at the top of your paper. Also remember to listen to the entire question and all of your answers before you choose the answer that you want to pick. As well, if I'm going too fast, you can always hit pause. And you can also go back and re-listen to a question if you need to hear it again. So let's get started. First, there's a table. In a laboratory, you produce a quantity of the radioactive isotope thorium-234. Over the course of several weeks, the unstable isotope decays, and you measure the amount of thorium-234 remaining in the sample. You obtain the following data. So how many days have elapsed? 0, 24, 48, and 72, and the grams of thorium-234 remaining, which are 8, 4, 2, and 1. Use that information to answer the next question. Number 1, use the data in the table above to determine the half-life of thorium-235. Explain your answer. Number 2, use the data in the table above to complete the graph below. So you're going to use the days elapsed and the grams of thorium and plot them on the graph. So you might want to hit pause to do that. Number 3, what are 2 geologic principles that geologists used to determine the relative age of rocks? Number 4, this rock has a vein of lava rock that squeezed its way in through the crack. What principle of geology would help you know that the vein of lava rock is the youngest? Number 5, actinium-225 has a half-life of 20 days. If you start with 200 grams of actinium-225, please fill in the chart to determine how much is remaining after 1, 2, 3, and 4 half-lives. Fill in the following chart. So the number of half-lives is 0, 1, 2, 3, and 4. You have to fill in how many days have passed, and then the grams of radioactive substance remaining. 0 has been done for you. You might want to hit pause here and then hit play again when you're ready to move on to number 6. Number 6, the half-life of carbon-14 is about 6,000 years. Determine the amount of C14 that would remain after 18,000 years if there was originally a sample of 40 grams. Please show your work. Again, this is a good one to hit pause so you can figure out your answer and show your work, and then hit play when you're ready to move to number 7. Number 7, 25% of a radioactive sample are left. How many half-lives have passed? Please show your work. Number 8, what are 2 ways that geologists determine the absolute age of rocks and fossils? Number 9. Please explain the relationship between a parent and daughter isotope and how half-life changes this relationship. Number 10, you're going to use a word bank to complete the sentences. First, I'm going to read the words that are in the word bank. Law of superposition, law of original horizontality, ingenious intrusions, or unconformities. So the first one says, blank are gaps in the rock record often caused by layers that have been eroded away. The next one, the blank states that younger rocks are laid down on top of older rocks. The next one, blank are caused by magma forcing its way into rock layers and then cooling. And then finally, the blank states that rocks are originally laid down in horizontal layers. Number 11, you're going to write an essay. So you're going to want to listen to the directions and then hit pause so that you can write your answer. Number 11 says, please write a paragraph or paragraphs that answer the following questions. 1, what are at least 4 ways that fossils can form? 2, what is an index fossil? 3, what is a trace fossil? And 4, how index fossils can be used to help date rocks. Again, hit pause so you can answer all 4 of those questions. Number 12, you're going to use the picture and you're going to number the events below in the order in which they occurred. 1 being the oldest and 12 being the youngest. You're going to want to hit pause here so that you can fill in those blanks. I'm going to read them to you though. J is deposited, M intrudes and crystallizes, K is deposited, I is deposited, N is deposited, L is deposited, H is deposited, P intrudes and crystallizes, J is eroded, L, M, N, O, P, and Q are uplifted and eroded, Q is deposited, and O is deposited. So you have to order them 1 through 12. What's the oldest? What's the youngest? Number 13 is a stratigraphic principle. You're going to label from youngest to oldest, off to the right-hand side, A, B, C, D, and E. You also have to state what the stratigraphic principle is. You might want to hit pause so that you can do that. 14, use the picture to answer the question and fill in the blanks. What happened last in this picture? The ingenious Pluton D or the earthquake fault line E? Which rock layer was put down first? A, B, C, or D? And which way did the rocks on the right move, upward or downward? For 15, you're also going to use the picture to fill in the blanks. What do you think caused the layers on the bottom to tilt upward? What are the layers on top? Why are the layers on top not tilted? And which law states that rocks are always deposited flat first? Hit pause if you need time to think about that.